Hi, my name is Spencer, and today we're going to be learning about redox. So, who knows what redox is? Have you ever heard of it?
No.
You never heard of it?
No.
Okay. So, a redox it's a classification of chemical reactions involving an energy transfer, and this happens when two chemicals come in contact, and one of them has a full valence shell, which is the most outer shell of an atom. And so when they have a full valence shell, they want to give off these electrons. And when they give off the electron to a element that doesn't have a full valence shell, that transfer creates an energy, a release of energy. And so that would be called redox. And what we're going to do is we're going to do a color change reaction, which is a redox reaction. And what we're going to do is we're going to use dextrose and sodium hydroxide. Now what happens is we're going to take 2.5 grams of dextrose. Just going to measure this out. Almost. Alright. So you put 2.5 grams of dextrose into what we're going to call flask A. And we're going to take 5 grams of dextrose I'm just going to let this level out. Alright. And so why do you guys think we're using dextrose?
Does
Any
it have
guesses?
a full valence shell?
The opposite. So if it doesn't have a full valence shell, but it's still part of a redox reaction, what does that mean?
That it doesn't have a full valence shell.
Exactly. So it wants electrons when it comes in contact with something with a full valence shell. And what this is called is an oxidizer. Because oxygen is the standard for things that like to take electrons. That's why it's called an oxidizer. Whereas we're using sodium hydroxide, which does have a full valence shell, and this is called a reducer. The reason it's called a reducer is because it changes the electric charge of what the oxidizer is, and it reduces it. It makes it a negative charge. This is called an oxidizer because of oxygen. It really should have been called like a increaser or something to that effect. But we're going to take this 5 grams of dextrose, and we're going to put it, once I take the top off, I'm going to put it into flask B. Alright. Just pour that in there. Alright, and now we're going to add 2.5 milliliters of sodium hydroxide into flask A. Actually, there's got to be a better way to do this. Pour it into here. It's water, it's okay. Alright, and pour a little bit of that back. Dang it. This is a really hard thing to balance out. Alright, just a little bit over. I'm going to take this sodium hydroxide and pour it into there. And then what we're going to do is we're going to mix this up. We're going to stop it actually for a minute. Just kind of let it sit there. And then we're going to fill this other flask B with 5 milliliters of sodium hydroxide. Okay. So now we have the two reducers and the oxidizers changing, but we're not going to see anything yet. And this is why we're going to take our methylene blue, which is an indicator.
Should you cover the
What's
other
an
ones?
indicator?
It's an it indicates the pH level of a water. And it indicates for right around 7, which is right about even. Right about in the middle of the pH scale. And what we're going to do so this is a powder. You should pause that.